What's up, guys? It's Ben from Pragmatic Software Engineering, and today we're going to talk about integers. So you may have heard that computers think in numbers, and that's partially true. To be more explicit, computers think in integers. To a computer, integers are the most natural way to express information. So a lot of things that don't really make sense as a numerical value are actually represented by integers. So the color green, or keys you see on a keyboard, the letters in a sentence, the letters in the alphabet, and even decimal numbers are all represented by integers. Because integers are so fundamental, every language I can think of has one. So Java, Python, C#, C++, C, JavaScript, HTML, Erlang, all of them have some sort of notion of an integer. Now, if I were to ask you, what is the first letter in the alphabet? You would say A. If I asked a computer, what's the first letter in the alphabet? It would say B. Computers always start with 0, while humans always start counting at 1. So if you were listening to Appetite for Destruction, and you wanted to listen to the first song, you would play song number 1. But a computer would play song number 0. And in another example, if you were the first customer on a website, you would be customer with ID number 0. You wouldn't be customer with ID number 1. The format integers are stored in a computer is called binary. And to explain what binary is, let's first think about how we do math as humans. We do everything in base 10 because we have 10 fingers. So if you were to add 1 and 9, you're adding them in the same digit, the ones place. And you cannot represent 10 in the ones digit. So you have to add 1 to the tens digit. It works very similarly in binary, except we're using base 2. Because a computer only understands on and off, you can only get those values 1 and 0, and you have to create these long numbers to encode or format, the number 20 or the number 500. Let's work from our most simple cases to more complicated ones to explain this. If you want to represent the number 0 in binary, you would just use 0. If you want to represent the number 1 in binary, you would just use 1. But if you want to represent the number 2, it gets a little bit more complicated. On the left, we see how a human does it. They add 1 to 1, they get 2, right? But for a computer, remember, the maximum number we can have in a digit, or actually in binary, we call this a bit. The maximum number we can have in a bit is 1. But the maximum number we can have in a digit for humans is 9. So if we go here and we add 1 to 1, now we have 0, 2, but that doesn't work in binary. So we have to carry the 1 over, and now we have 1, 0. If we do this with the number 3, you add 2 and 1, and you get 3. But if you added 1 to 1, if you added 0, 1, 0 to 1, or 3 and 1, you would get 0, 1, 1. So as of right now, there's no good way to say this number is negative and this number is positive. So in computer science, we've decided to actually split out the information of this number is negative and the actual number is information. So if we take the case negative 9, we'll split this out into negative 1 times 9. And we know the binary value for 9 is 1001. And what we'll do is we'll create a mapping of negative is 0 and positive is 1. Right? There's that integer mapping we see again. So now we have a way to represent negative numbers in binary. But not all numbers that we want to express to a computer are integers. At a core level, they are represented by an integer, but we want to tell computers about different numbers like decimals and really, really big integers. And we'll talk about this soon in the next video. Make sure you hit the subscribe button. Thanks, guys.